Can you hear me?
Yes, good morning.
Good, good, good. Okay. Every day I
Yes,
have the same
hello.
question, on whether it actually works or not. So where are we today? What are we doing? I did receive a couple of emails from you. I mean, predominantly when looking for, when I said that it would be good to hear from some of you in case you want something, that you haven't heard much of from this module. A couple of requests came through. One of them was specifically asking for solar, and one or two other were actually looking for solar plus something else. So in any case, today's class would anyway be dedicated to solar. So because it is clearly, one of the biggest contributors to the advances of renewable energy over the past decade, and quite surely what we're going to see a lot more of into the next 10 years at least. I think more than that, but yeah, for at least another 10 years, we will have no stop in the solar energy growth. So let me maybe ask quickly, do we have any burning questions for your coursework? Anything you need me to clarify, or I don't know, whatever you want to ask there?
Sorry, Professor.
Sure, go ahead.
Thank you. It's not actually on the project, but I was starting to work on it, and I had some notes from the last lecture about wind energy, but then I didn't find the slides. I don't know if it's still my problem, because
okay.
I found
it
only.
Could be my fault. It could be my fault, because to be honest with you, I don't remember what I've done, if I've uploaded it or not. I thought I did, but if you haven't found them, there is every chance I haven't.
Because like on the channel of the class, there are the ones from the last uploaded are from the 4th of October.
Okay, so it means I have left a couple of gaps there. Okay.
Yeah. So if you please can upload it. Thank you very much.
Okay, yes. And if I don't, please by all means send me an email with that.
Okay.
Yeah, because it's something. It is important, and we need to make sure that it's done. Okay, thank you. Anything else? Okay, I'm not hearing any takers. So,
hi, Professor.
Oh, here you are. Go for it.
Excuse me, I sent you an email Friday.
Yes.
On Friday, and I can't receive any answer from you.
Let me see. Yes, okay. So it's true. I can see your email. Yeah, that's Reza, yeah? Yeah. So I have your email. It's only that I received it. I took the weekend off. I know it's not normal for me, but I did it.
Thank you.
So, but yeah, don't worry. I will respond to you during the next day or two. I will do that. Okay.
Thank you.
Okay, you're welcome. So let's not delay anymore. Let's go directly to solar energy, because we have quite a lot to talk about. I mean, solar energy is an enormous subject. We will try to squeeze as much as we can today, but I mean, clearly, you could have a whole module about solar energy. It's quite easy. So let's do that. So can you see my slides now?
Yes.
Yes? Okay, good. So let's start then. So solar energy, everything you always wanted to ask, and you were too afraid to put the questions forward. So here we go. I'll talk to you about a few types of solar energy today. One of them will be, maybe before I say that, what types of solar energy do we have? Maybe you guys know already. Any ideas? Have you? I mean, I'm sure you've heard of solar energy, but what is it that you think normally when you hear about solar energy?
Photovoltaic and...
Correct. It's the photovoltaic panels. Anything else?
The solar oven.
Say again?
The solar oven, the one which concentrate the light.
Okay, solar oven. Yeah, that has gone relatively well. I don't know how many pieces have been distributed, but it was a good invention. Anybody else?
Then the one that we can find in Morocco, I think, which uses the light to heat a fluid, and then it generates steam.
Right, correct. So it's solar. It's kind of a thermal system essentially with a steam turbine. Yeah. Anything else? There is one that was a little bit more old school, and most houses had it. In Italy too, in the past at least. I don't know now. Solar for hot water, yeah, that's what I mean. So when you have that solar panel on your roof, which job isn't to generate electricity, but it is to just heat up the water you have for your shower, yeah? Do you know what I mean? Have you seen that?
Yes.
Yeah, okay.
Yes.
It is very common in kind of, Mediterranean countries. It's extremely common. So let's. I mean, it's not a high-tech device. Yeah, it's a very low-tech device, really. It's a black panel that has tubes going through it, so it attracts a lot of the solar radiation, and it warms up the water in the tubes, and then it stores that hot water in a barrel, essentially in a vessel that keeps it insulated, so it can stay hot for, I don't know, for a day or two, or it depends. In places that have, consistently sunny weather, even if it's not very warm, even if it's relatively cold outside, even in winter days, if it's sunny enough, that can warm up quite a good amount of water for showers or for use in the tap, washing or things like that. Yeah. So it saves quite a lot of energy, that system. Okay, so we have then at least 3 types, and we will be briefly talking about each one of them. So let me just show you a little bit of what I have at hand today. So it's the 3 types you guys mentioned
Professor,
before.
excuse me for interrupting.
Sure, yes.
Could you please record the lesson?
Oh, yes. Good point. Good point. Good point. Let me see how I do that without stopping the slides. Oh, God. Yes, I go here and then I press record. Yes, here it is. Thank you very much for the reminder. So let's go back to the slides now. Okay, here we are. So what we have then is these 3 types in particular that we will talk about. As you might imagine, the one we will talk more about is the photovoltaic PV panels. And the reason is that it's really the type of technology that has, really been changing all the renewable energy market over the last a little bit more than 10 years, probably about almost 15 years now. So let me tell you a few things about what you see there. So you've seen solar panels like these ones, or like these ones, or like these ones. I don't want to bore you with the very technical stuff, because I don't think this is what matters here. But I will go through all of that quickly. So solar radiation is received by a PV panel. PV panel generates DC power. So I'm not treating it as I don't want to talk to you about the photovoltaic phenomenon, because that's, I think, not in the scope of this class. But if you treat it as a black box, it's solar radiation falling on the panel. The panel generates direct current power, and that direct current is turned to AC with an inverter and then fed into the grid, or as DC, it can be stored in batteries or even used for DC applications, for direct current applications. Pretty much all the microelectronics you have at your house use DC, they don't use AC. So some consumptions can actually go directly with AC, sorry, with DC. And many others could be transformed. It's not that difficult, really. So that's, the very basic operation of what we have there. It's not an engine. It has no moving parts. So lots of benefits because of that. Because clearly, you have an energy generation system that essentially is maintenance free. I mean, almost maintenance free. It just needs a bit of cleaning, really. It doesn't need anything else. So it's pretty impressive in that sense. Let's carry on a little bit. I mean, that's the more technical side of it, on what you could get there inside, the electron movements and how that could be producing electricity for your panels. But like I said, I will not focus too much on that. I think it's a waste of your time right now to deal with this. I'll take you to this card, which you have seen. I think you've seen before. So first thing is to say efficiencies, and here I'm talking about the conversion efficiency. So the efficiency of improvement of converting solar radiation, so which is a type of energy, converting that energy to electricity. So that is in commercial panels, you will rarely see anything above 24%, and most systems really operate at significantly lower, like 15 to 20% is way more common. Then you have startup time that is rapid. So as soon as there is light on the panels produce electricity. But of course, it is not exactly on demand, because it depends on the weather and whether it's cloudy or sunny or all of that. And also it depends on the direct access that the panels have to the sun itself. Yeah, they can produce even without direct access, but it's not the same amount of production. Then use depends on availability and how sure you are about the availability. Typical capacity, this is per panel. Yeah, so I'm saying here 200 watts, which is a tiny amount of energy, but it is per panel. So it's not, I mean, if you see a solar farm that has numerous panels, then of course that can be, several kilowatts or even megawatts, depends on the size. Yeah. Installation time, again, depends very much on the size of the facility and whether you will connect it on the grid or not, and all of that. So it can be anything from a tiny amount of, a couple of days to several years if you're looking to install, hundreds of thousands of panels and link them to the grid with storage and so on. So it can vary quite a lot. Keep in mind that one of the major, let's say, benefits of solar energy, and we'll be talking a lot about it, is that, of PV energy, particularly photovoltaic energy, is that it's modular. It's extremely modular. So with wind turbines, you remember we were saying that, if you want to produce more energy from wind turbines, gradually what we have been seeing was a very significant growth in size of these wind turbines. So you're getting bigger and bigger wind turbines. Of course, you will, if you want more energy and you have a wind farm, you will have more wind turbines installed, so more items. With PV panels, we haven't seen a very dramatic growth in PV panel size. We have neither seen, a very significant growth on their efficiency. This hasn't, we've seen small incremental changes in the efficiency and some changes, some growth with the panel size. But in reality, most of the benefit has been in our capability to produce them much more cheaply. And as a result, install many more of them on the ground and just have, many more of them producing electricity. So that is the scalability of solar. Now, that allows for mass production. The beauty of that is mass production. So as a result, you have significant learning, industrial learning, which means prices collapse and means that essentially you can be getting better at producing them, at installing them and all of that, yeah, because of all the collective learning that you have there in the industry. It's, for example, the complete opposite from what you have, let's say, with nuclear energy. Yeah, there is no factory that makes, nuclear power plants. This doesn't exist, quite clearly. And as a result, nobody learns how to make nuclear power plants. There's very little learning being shared. There is one company building a nuclear power plant. It takes them 10 years to build it, or even more sometimes. There's no continuous production of, 1 million plants per year that will allow any company to learn how to build them very fast. It takes decades, and many decades really, until anyone is learning to do nuclear power plants, which in reality nobody does. Nobody learns very well how to make them. They just make it as they go. So yeah, it's quite a different setup. It's the two radical opposites. Let's go a little bit further out here. So some characteristics of these solar panels are that they generate, like we said before, direct current electricity. That means the electricity doesn't change polarity. Yeah, the electricity remains of the same polarity throughout the generation time. Now, PV energy is intermittent in a way similar to the wind, but not as bad. So it's more predictable, far more predictable, because we know very well what the sunshine hours are going to be. We know very well if our solar panels will be facing the sun based on their location, based on coverage for buildings, trees, whatever is around them. All of these things are very easy to predict, and we can also have a relatively good forecast of clouds. Whereas with wind speed, as we discussed, because it's the wind speed goes on the third power to produce electricity, any minor changes on the wind speed can really affect very significantly electricity production. So there's a lot more variation when it comes to wind. But with solar panels, it's significantly more predictable. You know far better what you're doing with solar panels than with wind. Main technologies here, and you will be seeing many more. You will be seeing polycrystalline panels, monocrystalline panels, and thin film systems. Now, these technologies, they started like that, and there are fundamental differences in their chemistry. But what is important for you to know is that these are very fundamental differences, and in reality, when you're looking at commercial applications, there has been so much progress with each one of these technologies that gradually we see a blend of efficiencies. Yeah. So in the past, it used to be that polycrystalline systems were of inferior quality to monocrystalline systems. So essentially, monocrystalline systems were seen as the best in terms of panel efficiency. They were a bit more expensive, but they were the most efficient. Thin films were pretty much rubbish. They were not very good in terms of efficiency. And polycrystalline were somewhere in the middle, but they were cheaper. Now, it's interesting that, of course, even though polycrystalline were not that good in terms of efficiency, they were the preferred panels by most large-scale installers. So most of the large-scale applications have opted to go for polycrystalline panels. As a result, manufacturing capacity for polycrystalline panels has grown dramatically. And as a result, exactly because there was a lot of money to be made in polycrystalline panels, R&D for polycrystalline panels has grown dramatically, which meant that essentially today's polycrystalline panels are not worse than most of the monocrystalline panels you can find. So that's why I'm mentioning all of that, but I'm being very careful in not letting you think something which is not valid anymore. So that is where we started, with monocrystallines being the top level of efficiency and polycrystalline being middle and thin films being worse. It's not necessarily the case. I want you to be looking at specific panels and looking at their efficiencies and understanding what is there. So go for a more interrogative approach than just take these as rules. Now, let's see a little bit what has been going on. So when we talk about an individual panel's productivity, energy production. That is typically to say that we're thinking of solar radiation of 1,000 watts per square meter, and atmospheric temperature around the panel being at about 25 degrees. Now, so these are the conditions we're normally thinking of. And there are two things that change here. So depending on where you are in the world, radiation can be significantly higher. So there are certain parts where, you know, the sun falls way more directly onto the Earth's surface, and it doesn't deflect with humidity, and it doesn't deflect with a vapor in the atmosphere very much, because it falls more directly down. And in these places, you will have significantly more than 1,000 watts per square meter. There are other places way up north where you will have significantantly less than that. So that's one thing to mention. And the other is that temperature, as you would imagine, can be significantly higher or significantly lower. Now, it's important to mention here that higher temperature means lower production of energy for these panels. So some of the, let's say, hotter places with more direct sunlight, even though they have much better sunlight reception, if the atmospheric temperature around there is very high and the panels reach, you know, 40, 50, 60, 70 degrees if they're under the sun directly, which that's where you put them, then that's not particularly good news for energy production. That can significantly inhibit energy production. So it's quite important to keep that in mind, even though some areas have much better radiation. Because of super higher temperatures, the production might not be what you expect it to be. Whereas if you are somewhere, you know, where the temperature is lower, but it's a clear sunny day, you could be getting, you know, a much better energy production, even if it's, you know, sub-zero temperature. So that's the kind of things, you know, we need to be thinking of. I'm also mentioning here that, you know, a typical 1 square meter panel will generate something between 100 to 200 watts, depending on the panel, the conditions, and all of that. That's for you to have a feel of, you know, what a panel can do. What can you run with 200 watts? Would you know? What kind of appliances at home do you have that run with 200 watts? Can you charge a car with 200 watts? Nobody?
Can you repeat, please?
Yeah, of course. What kind of use could you have for 200 watts of energy, of power? What kind of appliances at home run at this type of capacity? Any thoughts?
Water boiler or something like that?
A water boiler. Okay. You mean the one that you make coffee with or tea with?
Yes.
Of course, you would never use that in Italy. You would never make coffee with a water boiler. Sorry, that was... I take this back. I apologize for even mentioning. Okay, so water boiler to make a tea. Okay, you could use that. That is true, but it would require, most of them, if it's a very new model, it might be around 1,000 to 1,500 watts. If it's one of the, you know, the older ones, it could be around 2,000 to 3,000 watts. So you would need about, you know, 10 panels maybe to do something. 10 square meters. Yeah.
I have lights in the house which are more than 500 watt. So I think that with 100, 200, you don't do a lot.
Did you say you have lights at the house that are 400, that are 500 watts?
Yeah, halogen.
Oh my God, you have to trash them immediately. Don't use halogen.
Well,
Get LED. Get LED lights. They're a lot better.
yeah, I have a lot of them, but still I have these two, and I know it's 500 watt each.
Oh my God, okay.
Yeah, it's my mother's house, okay? It's not my fault. That's not the point.
I'm not blaming you, it's okay. But you need a whole power station to light the lights in your house.
So if a light bulb can go with 500 watt, it means that 100, 200 is not that
It's
much.
not a lot, yes. I have to say, I mean, it's not everybody's taste, but a lot has changed with light bulbs over the last, several years, as I'm sure you know. And one of the major advances, I would say, is the LED lights. And really, like, I'm having in my room now a perfectly fine LED light with, I think it's 11 watts, something like that. And it's really proper, it's like 100 watts of the old light bulbs. If you can put, a couple of them, it becomes annoyingly light, it becomes too much. So yeah, a lot has changed in that direction. I'd say lighting these days, you could do. It's probably one of the few things at home that you can do with very low wattage. You can also charge appliances, your phone, your laptop. Probably your laptop runs at about 100 watts, maybe 120, sometimes up to 150, thereabouts. This is the normal chargers that you have for your laptop. But yeah, if you want to do anything more significant, I don't know, start the oven, for example, your oven would normally be about 2,500, 3,000 watts, something like that. Yeah. So that is just, I'm having, this conversation to just say 200 watts is not a lot. So one panel, don't expect one panel to do miracles. You will need many panels connected together to start doing something useful at home, and you will need thousands and hundreds of thousands of panels connected together outside in a solar farm to do something at a country level, to be like a power plant. So it takes scale, but that's the beauty of solar. It does scale. It's not difficult to scale it. So let's move on then. So here I have a few curves that basically the only reason I have them here is to show you a little bit what's happening with different temperatures with solar radiation. So this is the energy production for one specific panel, and it shows the impact that the panel gets based on temperature. So what I want you to look at is not so much the curves, because the curves can confuse you a little bit, but see a little bit here the watts. This is the part I care more about. So imagine the radiation, it stays stable. Yeah, we don't change the radiation. It's exactly the same at 1,000 watts per square meter at a particular location. We only change the temperature from 10 all the way up to 70 degrees Celsius. And look how much the temperature, how much the production changes. So a panel which at 10 degrees was producing 333.7 watts, when you go up to 70 degrees, it will produce 257 watts. So it's a very dramatic drop of energy production. If you're wondering what it is that we're measuring here with these watts, that is, we multiply the current that you see here on the vertical axis, we multiply that with voltage on the horizontal axis. So what you are seeing here is, for example, your possibility to multiply a voltage on the gray line with a current it heats on the opposite side there. Yeah? So it's not a trivial change, I'm trying to tell you. So the same panel, say in a normal day in Norway, north, could be producing a lot more energy if the radiation was exactly the same, of course, but it's not. With a panel that is somewhere south, but the temperature is a lot higher. Only caveat on that, of course, and it's not trivial, is that the radiation is not the same. The radiation doubles and even more when you go south. So that's where you earn back a lot of this change here. Let's move on a little bit so I can show you a few more things. And by all means, do stop me if you have questions. Otherwise, I will keep on rushing because I have a couple of exercises I want you to try and play with today. So let me show you this one. So that's a very standard graph we have. I don't know if you, maybe actually this one is a better picture for you to see. So this is just south of London. It's a solar production output, and I want you to see how that changes with every month of the year. So this is just south of London, like I said, and I want you to see that, you know, if you're, say, the bottom part of this, which is around December, and it's December obviously because that's when the day is at its shortest, yeah. So you have the fewer hours of actual sunlight in the year, and that is something like 1100 kilowatt hours as a minimum. But then if you see what's happening during the peak period, which is around, you know, from May all the way to August, that reaches something like 6,000 kilowatt hours. So it is approximately 1 on 6, yeah. So it's not a trivial difference. It's a very, very substantial difference in energy production. So it's one to, you know, for us to keep in mind that solar panels are lovely, but you know, it's not exactly the most reliable source you have. So in summertime, they will produce significant amounts of energy. In wintertime, that really collapses. It's not the same at all. So it's okay if it makes sense financially for you, and if you need that energy in summertime or whatever. But it is tricky if you want to rely on them all year round for your electricity production. They're not particularly good at that. They're good often in combination with wind, because in many countries, wind energy peaks in winter. So if you combine solar with wind, there's a good chance that they will be complementing each other in the seasons. So you will have more solar in summer and more wind in winter. So the two of them summed up together will be probably getting to a much more stable curve than what you see individually from solar, individually from wind. So that's a significant issue. They also make a lot of sense if, for example, you're in a country that needs a lot of electricity for air conditioning. Yeah, so if you're in a country where the peak demand is because of summer cooling, summer air conditioning, then solar panels could be a fantastic idea, yeah, because that's exactly when you need them the most, they produce the most. But, you know, there are these intricacies. Not every system is perfect for every place and every situation. It has to be integrated correctly, and it has to fit the local requirements for energy. Or, of course, you can store it and do other things, but that's a whole other world. So that's in terms of variability over the seasons. And of course, I'm showing you the UK, which is not the sunniest place of the world. So let's move on from this. So here, it's a little exercise for you. And what I want you to do is really, you remember we've done something similar with wind energy last time. I want you to go online and find the PV panel manufacturer and get a product and come back and tell us all about it. So it will be a solar panel, and I will want you to look for information like, you know, the physical size of the panel, its warranty, maybe even its cost. You might be able to find cost information much more about solar than it was possible for wind. You might be able to find, I mean, you will definitely find, you know, productivity, you know, if what is its efficiency, or what is the output that you expect to get, the nominal output you expect to get, or things like that. So I want us to play a little bit with this idea. I mean, I have to clarify here, solar is a lot more consumer-centric than wind, yeah, quite clearly. Because wind turbines, you remember, the large one especially, they would cost hundreds of millions. Solar panels are not like that. They're very cheap, because you can get one solar panel, of course, yes, so it can be really, really cheap in that sense. So it's a lot easier to find. It can be a lot more retail market kind of product. So let's do this little exercise. What I'll do is I'll go here, and I'll try to see how to break you in groups. So this will take a few seconds, as it always does. So how many are we here? We're not very many today. I can see 25 people. Are we even 25? Yes, we are. Good, okay. So what I'll do is I'll take us to maybe 5 groups and go automatically. Let's do this. So I'll send you now to your groups, and then, like we've done other times, I'll be visiting between your groups to have quick discussions with you and make sure you make progress. So I'll see you all in a few seconds within your groups now.